Hello, and thank you for joining us from wherever you are in the world right now. Welcome to Launch 5, our latest OneWeb satellites launch. My name is Maurizio Vanotti and I will be your host today. Shortly, we will see another 36 OneWeb satellites joining the 110 already flying in our constellation at 1,200 kilometers above our heads. This is the 5th launch in our mission sequence, and is the latest exciting step in our continuing journey to connect the unconnected, thanks to high-speed internet from space. This project is about providing new opportunities to people and businesses, from access to learning to enabling new ventures to government services. And you can watch with us as our latest satellite batch take flight, live from the Vostochny Cosmodrome. OneWeb's network is designed to enable a better connected world if we are to narrow the digital divide that separates people and businesses. Even as more and more of us move online, we still have significant gaps, not just in terms of availability, affordability, and access to broadband. By the end of this year, OneWeb infrastructure will deliver continuous connectivity at latitudes higher than 50 degrees north, introducing commercial service in the UK, Northern Europe, Canada, and Alaska. OneWeb will connect you with fast internet and low latency, whether you are at sea, airborne, or in the middle of nowhere, providing truly global coverage by 2022. And in the past year, we've seen more than ever the importance of being connected to each other. It's why we are committed to a revolutionary network in low Earth orbit. And it's why we're here today. Thank you for joining us. None of that would be possible without the support and expertise of our colleagues at Arianespace. And the countdown to today's launch began many months ago. The Soyuz ST-30 rocket will launch us into orbit within the next 15 minutes. So let's now go to Stéphane Israël, the CEO of Arianespace, for an update to their preparations.
Ladies and gentlemen, good evening. I am in Évry from our remote flight desk with my colleagues of Arianespace and Starsem. I want to thank all of you for being with us for this 5th launch for OneWeb. We are going to deliver 36 more satellites. The mission will last 3 hours and 51 minutes. The separation will be 4x4, and we will deliver the satellite at an altitude, separation altitude of 450 kilometers. Then the satellites will go by their own means to their final altitude at 1,200 kilometers. I really want tonight to thank all our teams which have been involved in this campaign. In Vostochny, I want to thank our Russian partners with whom we have an outstanding cooperation. And for sure, I want to say my recognition to our trusted customer, OneWeb, with whom we are now building an incredible journey. So we are now a few minutes from the launch. All the news we have are positive to go for the liftoff in a few minutes. But let's wait now for the final countdown and enjoy the launch with all of us. Thank you very much.
Thank you, Stéphane. The launch of our satellites today is the first step on a complex journey for them to get to the final destination in orbit. So let's look in a bit more detail at that journey. Joining me now, and for the rest of the broadcast, is Vincent Baudel, the Advanced Studies Director at Arianespace, who can take us through the launch step by step. Welcome, Vincent. Would you like to take us through the next launch sequence?
Hi, Maurizio, and hello, everybody. I'm very happy to be with you tonight. So, well, tonight's mission of the Soyuz will start with the booster, the 4 booster phase for a duration of approximately 2 minutes. After their separation, the second stage of the launch vehicle, that is to say the core stage, will take the reins during less than 3 minutes, and the fairing will then be jettisoned. A few seconds before separation of the core stage, the third stage will be ignited, and the central core will then be separated. 9 minutes and 22 seconds after liftoff, the first stage will be separated from the nose module. The nose module, includes the frigate upper stage, the dispenser, and the 36 OneWeb satellites. The frigate upper stage mission will start with the first ignition of its main engine in order to reach the intermediate transfer orbit, followed by a long ballistic phase. A second ignition will be performed for circularization and injection into the satellite separation orbit. The satellite's release sequence will start with first the separation of the 4 satellites integrated on the top conical part of the dispenser, and then successive separations of the 32 satellites integrated on the cylindrical part of the dispenser from the top row to the bottom row, and 4 satellites at once. So as illustrated on the 3D animation, it means that 9 separation events are necessary for the complete release of the 36 satellites. And between each separation events, the sequence is identical, so 19 minutes, which consist in a series of maneuvers. So firstly, a tilting of the nose module, then a boost of the frigate attitude control system with a very small delta V during few seconds to ensure enough distance between the satellites and avoid any collision. Then a new tilting of the nose module to the required orientation for the satellite separation. And the separation is ordered by the frigate upper stage, a smooth separation ensured by a relaxation of a specific spring. So the end of this complex release sequence occurs a little bit less than 4 hours after the liftoff, with the last and the 9th satellite separation.
Vincent, thank you. I hope that helps you to understand the journey that awaits our satellites very soon. This is how we're going to be able to bridge digital divides, but now let us look for a moment at who will benefit. When we talk of connecting remote communities, you may think of mountain villages in Tibet or remote communities in Africa. And this is true, but there are several examples closer to what we think of as a developed world. One of these is the US state of Alaska, where the limitations of ground-based communications still leave communities and residents isolated. Liesl Maguire, OneWeb advisor and former Alaska state senator, will explain more.
Happy launch day to the entire team of OneWeb. Your Alaska team on the ground is excitedly watching alongside all of you. Today's launch represents one more milestone in the important journey that we have all been on to deliver fiber from the sky to some of the least connected people on the planet. I joined OneWeb 4 years ago because it was the only LEO spatial constellation project that made a commitment to covering Alaska and the Arctic first. What an exciting day for our people. The pandemic has only highlighted the challenges that we have here. More than 40% of the people in our state remain under and unconnected, separating search and rescue teams from their victims that are in peril, separating doctors from their patients, separating students from their teachers, leaving generations of people in the Arctic and Alaska behind. OneWeb's commitment to the people of our state and the Arctic is nothing short of miraculous. In a state and in a place that ends up being last for almost everything and first in a lot of things we wouldn't like to be, finally today we're one step closer to the dream of being connected the way that so many people on the planet are. Congratulations to the entire team of OneWeb. We look forward to another successful launch and to launching our service here in the state this summer.
Thank you, Liesl. I think that video shows exactly why we're doing this, to give equal access to healthcare, to education, to business, to all. And to show you exactly how it will work on the ground, we are now joined by Chuck Schumann, a dear friend and CEO of Pacific Dataport.
Welcome to Talkeetna, Alaska, site of OneWeb's Gateway, or SMP, for Alaska and the North American Arctic. Hello, I'm Chuck Schumann, CEO of Pacific Dataport. We're working together with OneWeb to finally bridge the digital divide in Alaska with OneWeb's high-speed, low-latency connectivity. Pacific Dataport was founded to solve the lack of connectivity in Alaska. We share OneWeb's vision to connect everyone, everywhere. I have worked in satellite communications here for over 40 years. This is by far the most exciting time for me to see that vision come true. We selected OneWeb to work with because of their commitment, vision, and willingness to work with local partners to deliver a solution that will serve all of Alaska. I'm standing here in front of Denali, the Great One, which is the mountain behind me, to tell you about OneWeb's project to provide the world with high-speed, low-latency connectivity. It starts here at the Talkeetna Teleport. The antennas behind me communicate with the hundreds of OneWeb low Earth orbiting satellites orbiting the Earth. At any given time, there will be several satellites above Alaska that can see and communicate with this SMP. The satellites then communicate with user terminals like this. We call these UTs. UTs can be located anywhere in Alaska, at a school, health clinic, community Wi-Fi, a business, or a wireless service provider. Anywhere with access to a OneWeb UT will be able to communicate back to Talkeetna through the satellite and then be connected to the internet. With this launch, the excitement is building in Alaska. Soon, Alaskans anywhere in our state will be able to connect to everywhere. Best wishes from Talkeetna to the OneWeb launch team. Let's connect Alaska. Go OneWeb.
Thank you, Chuck. At OneWeb, we believe partnerships are the way forward. Our local partners like Pacific Dataport in Alaska are essential to the success of our global mission. We look forward to connecting Alaska, and today is a big step in that journey. Now, it's almost time for liftoff. We're going back to Vincent Baudel at Arianespace, who's going to talk us through the final moments in the preparation for launch. Vincent, over to you.
Well, the first combined operations have consisted in the integration of the complete stack of the 36 OneWeb satellites on the frigate upper stage, and followed by the encapsulation phase with the fairing installation. This upper composite has then been transferred to the launcher integration building, where it has been integrated and finally prepared on top of the Soyuz 3 stage. And 3 days before the launch, as you can see on the video, the complete launch vehicle has been transferred to the launch pad. Once arrived on the launch pad, the launch vehicle has been vertically tilted and the mobile gantry has been safely installed around the launcher. The launch pad operation has then been initiated with line connection, setup, and laptop verifications. And finally, the countdown and dress rehearsal have finally been run successfully at D-2, so 2 days before the launch day.
It's great to see the rocket in position. This may be our 5th launch, but it's just as exciting as the first one for the OneWeb team. Vincent, what's happening in the countdown? How are things looking?
Well, final ops are running as expected. So the beginning of the launch vehicle final automatic sequence has been initiated manually at I0 minus 5 minutes with a turn of key in start position. So it is an operation called Kluch na start in Russian, so key on start. The purging operation are as well ongoing. And on frigate, the transfer has been done to the onboard power supply. So right now, 2 minutes and 25 seconds before liftoff, the umbilical connectors will be separated. So it will be done very, very soon. And before this connection, the communications between the ground and the launcher upper part were provided by this electrical link. So in the meantime, there is pressurization of the Soyuz 3-stage tanks. And 45 seconds before liftoff, the transfer will be done to the 3-stage onboard power.
Thank you, Vincent. We've got a long journey ahead of us. We have a lot of satellites to drop off at different locations. It's a complex mission for Soyuz and will be just under 4 hours. Vincent, can you talk us through what's going to happen in the final seconds before liftoff and the ignition sequence?
Well, concerning this ignition sequence, so we will have a progressive increasing of the thrust level. So this progressive sequence will enable to check that the engines work nominally. First, there will be the ignitions, 16 seconds before liftoff. Then a preliminary thrust level, 20% at 11 seconds before liftoff. The intermediate thrust level, 85% 4 seconds before liftoff. And finally, at liftoff time, we will have the full thrust level.
Thank you, Vincent. We are less than 1 minute from liftoff. I guess you've seen maybe tens, if not hundreds of launches. How do you live these moments, Vincent? What are your feelings? We obviously are pretty tense and excited at the same time, but from your perspective, how do you live these final stages?
So it's always a particular moment and a fantastic moment. So as well some, I would say, emotional moments. So as usual, so it is a famous rocket you will see tonight. So let's go, yes, with the final sequence.
And this time we're going to be able to enjoy a daytime launch. When we launched in December, it was a night launch. So let's look at it from a different perspective. Enjoy the launch.
Предварительная. Промежуточная. Главное. Подъем.
Прошел контакт подъема. Двигатели центрального и боковых блоков вышли на режим главной ступени.
Very exciting. So today we are launching in plane 7 of our constellation. This is the reason why we are launching at a particular time of the day. We are going to plane 7, and it's a long way to go. It's going to be a 4-hour journey before all the 36 satellites will be released. At present, the boosters are doing all the work. They're pushing up against the Earth's gravity, and they will burn all their propellant in just under 2 minutes. Vincent, can you briefly explain how you're getting telemetry from the rocket?
50 секунд. Давление в камерах сгорания двигателей ракеты.
Yes, so we have the
60 секунд. Полет
sorry,
нормальный.
yes, Maurizio. So we are getting the information from teams in the CVI.
70 секунд.
So the control
Параметры
visual
системы
media in
управления
French.
ракеты-носителем
So
в норме.
this is in fact, this operation team is tracking the launch vehicle and receive all the telemetry data from the launch vehicle. So they can consequently confirm when the major events during the flight have occurred.
Thank you, Vincent. And we also have a live feed from the rocket itself. So we're looking forward to receiving confirmation of the jetson of the boosters. Actually, we're going to be able to look at it in real time. So after the boosters have burned all the propellant, we don't need them anymore. So that is part of the plan. And we're going to be shedding weight just 1 minute and 58 seconds after the launch. And we have the jetson of the boosters. Fantastic. So Vincent, everything is nominal so far.
Yes, everything is nominal so far. So just before the separation, so we have the maximum acceleration level at the end of this first stage flight phase. So the first stage of the launch vehicle consists in four boosters arranged around the central core. So 45 tons each, and each powered by an ARD 107A engine, and producing a total thrust of 340 tons at liftoff. And of course, their job is to get the launch vehicle away from the Earth. So we have the confirmation of this good separation, yes.
So the next step will be the fairing separation, the jetson of fairing. So yes. While we look forward to this moment, take us through what's happening right now on board of Soyuz ST-30.
Yeah, so maybe few words about the fairing, and that has several jobs. So most notably, it's protecting the satellites from severe conditions of the launch and atmosphere. So there is the acoustic vibrations at liftoff, and also frictions when the launcher is flying through the dense part of the atmosphere. So at a very high speed.
And we've just seen the jetson of the fairing in real time. That's
at the present
fantastic.
altitude, yes, there is no more atmosphere, so no need to maintain the fairing on the launcher to protect the satellite. So the launcher is liberated from any dead weight. So we can confirm now the effective and correct separation of the fairing.
Thank you. And it's also interesting to try to visualize what's inside the fairing. So the satellites are attached to what is called a central dispenser in a configuration that resembles a corn kernel. The satellites themselves have a shape of a truncated pyramid. That is the configuration that maximizes the number of satellites inside the fairing itself. And as you can see in the image, you can notice the two gateway antenna reflectors that are responsible for the Ka link with the gateway stations, while the user link antenna is shaped like a fanned-out deck of cards. And that is the antenna that is responsible to connect the user terminals to the satellite. So we are now at the end of the second stage phase. And Vincent, tell us what's going on.
So yes, during the second stage flight, there was a maximum acceleration level just before the separation of the second stage. So the second stage is now separated, and it's a turn, as you can see on the 3D animation, the turn of the third stage to burn. This third stage is powered by one RD 124 engine, producing a thrust of 30 tons. It will burn for approximately 4 minutes and 30 seconds.
Thank you, Vincent. Our mission has many direct benefits, but we also want it to be an inspiration. We want everyone to see the possibilities and the excitement in space science, and for some people to be inspired enough to choose it as a career. Space scientist Dr. Maggie Adorin-Pocock has played a key role in encouraging students to think about careers in space and science. She joins us now to give her view on what this project can do to inspire people to look to the stars for their future.
Hi, I'm Dr. Maggie, and I work as a space scientist. And I'm very lucky because I love my job. Working in space gives you opportunities that are literally out of this world. Through my career, I've worked on sort of the James Webb Space Telescope, the largest space telescope ever built. But I've also worked on Earth observation satellites that give us a better understanding of our planet. Space truly does cover it all. But there's a space here for you too. Many people think that as a space scientist or working in the space industry, you have to be a rocket scientist. And that's so not true. The space industry is very diverse. We need people of all sorts of disciplines. If you think about it, in an industry, you need human resources, you need PR, you need finance, you need all these different people, legal, all coming together to make a company work. And it's just the same in space. So if you've always been reaching for the stars and looking out there, maybe there's a place in space for you. Do join us because we have a fantastic time. One of the things that I love about space is just the diversity, meeting people from other countries. Space is truly global, but space is truly thriving here in the UK. Over the last few years, the space industry has been booming here, and we're diversifying and doing many different things. As a Black female scientist, when I tell people I'm a space scientist, they look a little surprised sometimes. But space is a global enterprise and it needs a diverse workforce. And that workforce could include you. Do join us. It's a lot of fun.
Thank you, Maggie. And don't forget to look out for jobs that are on our website. The launch phases are always extremely exciting, and we are looking forward to confirming stage 3 separation. While waiting for that, let's take a moment to highlight that we are deploying our ground network infrastructure as well. And this is a key element, which are the satellite access portals distributed across the globe that will enable commercial service introduction by the end of 2021. Vincent, where are we at right now, and when do you think we're going to be able to confirm the stage separation and the frigate ignition?
Yes, so we are in the third stage flight, so all the parameters are nominal, so everything is fully on track, okay? So in a few seconds, there will be the ignition of the third stage. And just after, yes, you can see the 3D animation of the third stage separation. And well, now it's the frigate upper stage is now getting ready to switch on its main engine. So the first step is called the pre-burn phase for a duration of 55 seconds. It's giving a quick burst of acceleration, so to push the propellants or the fluids back to the tank. Like when you accelerate in a car, you get pinged back against the seat. So this is the first step of the frigate mission. This first ignition enables to inject the nose module into an intermediate transfer orbit, so an elliptical orbit. And the duration of this boost is just over 5 minutes. So we will be able to confirm now the ignition in few seconds, yes.
Thank you, Vincent. So the next phase of the journey started, and the frigate is really the smartest part of the rocket, with its own brain, its own onboard computer that is responsible for reigniting the engine, reorientating the upper stage, and its job is ultimately to deliver the satellites where we want them to be. So we call it our celestial bus driver. But now let's have a look at the performance of our user terminals.
Here we are connecting to the OneWeb satellite on this orbit. So here we have the satellite number 95, which go over Florida.
Very confident about this one.
Yeah, it's going quite well. The SNR are good, and the data rate seems very good, so perfect. Yeah, the SNR is the ratio between the signal received and the noise at the terminal side. So this is a metric that we are using to assess the quality of the communication. So here we have around 15 dB SNR, which is very good. And we managed to get 500 megabit there.
Wow! That's great. So 32 is
39, 36.
So I think what's really key here is that, like, I can see you guys speaking, and the sound is complete. The latency tells the story here, right? This is perfect.
Here you can see that there is two Antillean antenna, which are tracking our satellite and switching from one satellite to another when there is handover.
Seeing here is every couple of minutes we hand over, every 11 seconds we're handing over beams, every few minutes we're handing over satellites. But there's no impact on the team session, right? There's no pixelation, there's no jitter. Perfect.
It's great to see OneWeb in action. We are now at just roughly around 13 minutes after liftoff, and let's have another look at launch of ST-30 that just happened. Vincent, what are your feelings right now? So far, everything has been nominal.
Yes, everything has been nominal. So we had the confirmation of the first ignition of the frigate main engine. So Everything is going nominal. So as you can see on the video, yeah, always a spectacular and emotional moment. So far, ops are running as expected. So the flight operation are running as expected. Of course, here in France and in Russia, we are still tracking the launcher. So well, to be quite specific and perfectly precise. And as usual, statistics speaks for themselves. So the tonight's launch is the 1936th Soyuz launch since the introduction of this famous rocket in the 60s as a workhorse of the Soviet and Russian space program. So it is quite fantastic and a spectacular launch record. So, and to be noted as well that tonight's launch is the second purely commercial launch from the Vostochny Cosmodrome in Siberia. The first one was, of course, the previous OneWeb launch successfully performed in last December.
And it's been a very long launch campaign for the launch team that is out there in Vostochny, Siberia right now. Not only they had to face the challenges and the intricacies of the launch campaign, but also the challenges imposed by the COVID restrictions. So they had to quarantine in Moscow for 2 weeks before transfer to launch site in Vostochny. So thank you very much for their support, their effort, and for being away from their families. Vincent, what is the status of the frigate right now?
Well, we are at the end of the first ignition. So in few seconds, it will be the scheduled moment. Yes, it is the scheduled moment for frigate to switch off its engine. So we enter now a ballistic phase. We are traveling high enough and fast enough to cruise without the engine. So during this phase, we optimize the orientation of the launcher in order to ensure the best condition for frigate and the 30 satellites. So this ballistic phase is done with a barbecue mode during 45 minutes. Barbecue mode, so that is to say a rotation around of the nose module around its longitudinal axis. So it is done to optimize the thermal conditions and the sun illumination of the frigate upper stage, and of course of the satellites.
So the next phase of the journey starts after the ballistic phase, and take us through the next steps.
Yeah, so after this long ballistic phase, there will be a second ignition of the frigate main engine. So in order to circularize the orbit and to inject the nose module into the satellite separation orbit. So this second ignition has a very short duration compared to the first ignition. So only 32 seconds. And after that, there will be 9 successive separation events for the complete release of the 36 satellites. And between each event, each separation event, there will be a boost of the frigate attitude control system with a very small delta V during a few seconds in order to ensure enough distance between the satellites and to avoid, of course, any collision.
What is going to happen over the next few hours is that the frigate will perform a series of 9 school bus drop-offs, as we like to call them, releasing our 36 satellites in groups of 4. In doing so, we have to remember that the frigate has 1 gear only, so it's a school bus with 1 gear only, which means that after each satellite separation, we have fewer satellites attached to the dispenser, which will make the core kernel lighter. For this reason, the frigate will have to fire for a shorter period of time its thruster. Also, note that in doing so, we're actually slowing down, which means that the first satellites we separated are ahead of us. After separation, the LEOP starts, and our satellite operation centers between London and Virginia will take control of the satellites. Now, the importance of being connected is something we've all seen this year. It is also something that has inspired our CEO, Neil Masterson, who can join us now for a quick update on the OneWeb rollout.
Expanding access to connectivity is becoming central to modern day life. It is central to the digital economies, to economic growth, to education, to healthcare. Look, we've all experienced it during the time of COVID, how important it is to be connected. And in many ways, it's becoming close to a necessity in the modern world. We're moving at real pace, and I'm delighted by the progress that we're making. In addition to relaunching our satellite production lines, we are launching satellite, we are engaging with customers. We're seeing a lot of demand and a lot of interest for our services moving forward. And we're very excited to be rolling out our service. So for those of you watching, I hope you're sharing our excitement. We have a lot of visibility, and that's why we're so excited. We have launches coming up during the course of the summer. We're also, the pace of network build out that we're embarking on, I think is unprecedented. We are moving very quickly with real speed, real precision, and real determination.
Thank you, Neil. And with these words, we are at launch plus 19 minutes and 30 seconds. Our fifth launch is underway, and the latest batch of OneWeb satellites will soon be on their separation altitude of 450 kilometers. Soon, they will make their way to their predetermined mission orbit, 1,200 kilometers above the Earth. At that point, we will have 146 satellites in orbit, placing us 1/4 of the way in achieving our connectivity mission. Over this past year, we've all seen the importance of being connected to each other, whether that be for scientists and doctors to work together efficiently, or simply being able to see our friends and families. And for our team, it's been a personal mission, this year more than ever. Behind every single one of our satellites is a team of over 200 OneWeb colleagues in many countries across the world, from designers and engineers to manufacturing, finance, legal, human resources, commercial, IT, and logistics. They're working side by side to support our singular aim, to connect us all. I would like to take this moment to extend my personal thanks to each and every one of them. Your efforts, our efforts, every day have brought us to this moment. Also, my many thanks to the team at Arianespace, and in particular Stéphane Israel and Vincent Baudel, who joined us today, and the colleagues from OneWeb Satellites in Florida. Without their support and expertise, we simply could not fulfill our mission. Together, as one team, we are changing the world. This is the year OneWeb will bring opportunities to all, through new network solutions that can apply satellite and broadband technology in more universal and smarter ways. Our launch animation will continue to be broadcast, so you can see the satellites being separated. You can also follow our mission and progress across the OneWeb social media channels. We are going to transform the way you think about connectivity and how you use it. Our next launch will be in April, another step towards our goal. From me and all the OneWeb team, thank you for watching, and we will see you in April for Launch 6. Thank you and goodbye.